Alright, in this video we're going to talk about section 1.2 day 2, the domain and period of the sine and cosine functions. So if we think about domain, that's what we can put into these functions. So if we look at the unit circle and the x, y values, we need to remember that the x values are cosine and the y values are sine. So if we think about what goes in, we're putting an angle into sine and cosine and getting that answer on the xy point out. So we can really put any angle in to sine and cosine because we can go any direction around the unit circle, positive or negative. We can go around the unit circle infinitely many times, so we can get infinitely large numbers. So our domain for both sine and cosine is going to end up being all real numbers. Now, if we want to look at the range, we have to think about sine and cosine as functions. Remember that the output of our sine and cosine functions are going to be y and x respectively. So we put an angle into cosine and we get the x value of a point on the unit circle out. So we don't want to think about the points on the unit circle as x and y's, but we want to think of them as the output of cosine and sine. So if we look the smallest x values and the smallest y values, so the smallest sine and cosine values are going to be -1 and the largest are going to be +1. So that's going to give us a range of -1 to 1 for both sine and cosine. Now, we can also talk about how sine and cosine are periodic. So to illustrate what we're talking about, we're just going to look at sine of pi over 6, 13 pi over 6, and 25 pi over 6. So sine of pi over 6 is one that you should know. It's going to be 1/2. Now if we think about 13 pi over 6, that's really going all the way around the unit circle one time, and then another pi over 6. So really we're just going to end up at the same spot as we did here. So that's also going to be 1/2. 25 pi over 6 means we're going around the unit circle 2 full times and then another pi over 6, which means we're ending up where we did here again. So the sine of pi over 6, 13 pi over 6, and 25 pi over 6 is really just 1/2. It's the same thing each time. So what we want to notice is the fact that 13 pi over 6 is really 2 pi plus pi over 6. So once around the unit circle plus that pi over 6. 25 pi, oops, not 2, but 4 pi plus pi over 6. So this is going to show that sine is going to repeat every 2 pi radians. If you wanted to do the same thing with cosine, you could do that as well. So our definition of a periodic function says that there has to exist a positive real number c such that f of t plus c equals f of t. So you're getting the same value out as when you plugged in 2 different x values. For all t in the domain of the function, the smallest number c for which this function is periodic is called the period. So the first time you repeat basically is what this is saying. So for sine and cosine you repeat once around the unit circle, so our period is going to be 2 pi. Now we can also think about even and odd functions. So recall that if a function is even, we know that f of negative x is going to equal f of x. And a function is odd if f of negative x is equal to negative f of x. So looking at your unit circle, looking at the values for sine and cosine, you can kind of look and see which of these values, sine, cosine, tangent, secant, cosecant, cotangent, are going to be even and which ones are going to be odd. So the ones that are going to be even are going to be cosine of x, or t, and secant of t. And the fact that those two are paired together shouldn't be that big of a surprise because there's a direct relationship between cosine and secant. And then the other 4, sine of t, cosecant of t, tangent of t, and cotangent of t, are all odd functions. So we can kind of use those to help us figure out the values of certain sine functions, or certain trig functions rather. So the example that we'll do, and then we'll finish up with this video, is going to be to evaluate sine of 9 pi over 4, cosine of negative 9 pi over 2, and to find sine of negative t given that sine of t is 4/5. So we know that for a, sine has a period of 2 pi. So 9 pi over 4. We can really think of that as 2 pi plus pi over 4. So we know the period is 2 pi. So this is just bringing me around the unit circle once and then going to pi over 4. So we can really just think of this as pi over 4, which is going to be radical 2 over 2. For b, when we're looking at cosine of negative, I should say cosine of, not cosine equals, cosine of negative 9 pi over 2, we can think of that as cosine of negative 4 pi minus pi over 2. So we're going to look at that. That's twice around the unit circle. So really this is just going to be the same thing as cosine of negative pi over 2, which if you want to make that a positive angle is going to be the same thing as 3 pi over 2, which is just going to be 0. And then finally, sine of negative t, given that sine of t is 4/5, well, we know sine is odd, which means sine of negative t is going to be equal to negative sine of t, which is going to be equal to negative 4/5. So we'll call it quits on the video there, and we'll see you in the next one.